Hi, in this video, we will look into LL1 grammars. As in the previous video, we have looked into simple grammars, quasi-simple grammars, and now we want to look into LL1 grammars. Okay, let's see the definitions for each of the grammars that we have looked before this. For simple grammar, the grammar, there are two conditions for the grammar, the restrictions for the grammars. First is the grammars must be in the forms of A, which is a non-terminal, goes to a terminal, okay, it starts with a terminal, and followed by alpha. Alpha can be a terminal or a non-terminal. Okay, so that is a simple grammar, okay. Then a quasi-simple grammars, it is actually derived also from the simple grammar, but it add on another rules, which is a non-terminal goes to epsilon. Means that it consider an epsilon inside the quasi-simple grammar. Okay, now inside the LL1 grammar, they have in the form, the LL1 is in the forms of a non-terminal will goes to alpha. So this alpha can be a terminal or a non-terminal. So the difference here is the LL1 grammar can begin with a terminal or as well as a non-terminal. Compared to a simple and quasi grammar, it must start with a terminal or an epsilon here. So for LL1 grammar, the grammar must be such that any two rules defining the same non-terminal must have disjoint selection set. This is actually is quite similar to simple and quasi grammars. Okay, means that they have a disjoint selections set, different selection sets. Okay, so we can construct a one-step push-down machine parser or a recursive descent parser for it. So this is also similar to simple grammar and quasi-simple grammar, where we can construct a one-step push-down machine as well as a recursive descent parser for LL1 grammar. Okay, here is a definitions for the LL1 grammar. LL1 grammar is a context-free grammar. Okay, with grammar we contain VT for the terminals, VN for non-terminals, S for the start, and P for the productions rules, whose parsing table has a no multiple entries is said to be LL1. Okay. So in the name of LL1, what actually is LL1? The first L stands for scanning the input from left to right. Okay, the first L indicate left to right. It's scanning the input from left to right. It's a left derivations. The second L, okay, the second L actually stands for producing a leftmost derivations. Okay, first one is from left to right. The second L is leftmost derivations. Okay, and the one stand for using one input symbols of a look ahead at each steps to make passing action decision. So only one input symbol. That is what we call as LL1. Okay, let's look into these examples of LL1 grammar. We notice that the difference here would be, if you look into rules number 1, it starts with a non-terminal A. Okay, compared to grammar, a simple grammar and quasi-simple grammar, it starts with a terminal. Okay, so this would be the difference between the simple and quasi with the LL1 grammar. It can start with a non-terminal as well. Remember, LL1 is in the forms of N goes to alpha. Okay, so alpha can be a terminal and a non-terminal. If you could remember, in the simple grammar and quasi-simple grammar, we are finding a selection set So the selection set actually is the first terminal, the first string on the right hand side of the rules. Okay, so in this grammar, if you can see, the first rule is a non-terminal. So we didn't know what would be the selections rule for the first rules here. A selection set for the first rules here. The second rules here, it starts with B. So the selection set is B. Okay. And the third one is epsilon. Again, we didn't know what would be the selection set. If in the quasi-simple grammar, we need to find a follow A in order to find selection set for A. Okay, that is how you find the selection set. You need to find follow A. In this case, in the quasi-simple grammar. Okay, and rule number 4, the selection set will be C. Okay, so if you look into this grammar, we didn't know what would be the selection set for rules number 1 and also rules number 3. Okay, then in this video, we will look into a step to find an algorithm to find a selection set for this kinds of grammar, LL1 grammar. There are 12 steps altogether that we will look into in a next slide. Okay, here is the 12 steps to find the selection set for LL1 grammar. We will look into each of these steps in more details. Okay, so this is the summary of the steps, 12 steps that we need to go through in order to find the selection set in LL1 grammar. It starts with find a nullable rules and nullable non-terminal. Actually, nullable is an epsilon in the productions rules. And the second step is to find a begin directly with relations, BDW. We will look into it later. Again, the third step is find begin with relations, and the rest of it, okay, we will look in detail in the few slides after this. Okay, so this is the dependency graph for the steps in the algorithm for finding selection set. This graph is just to show you that how one step relate to each other. For example, here, if you look into step 2 here, actually it would mean in order to do step 2, it need informations from steps 1. Okay, let's see steps number 9 in the middle here. If you see the arrow here for steps 9, the arrow that coming in is from 6, from number 3, and from number 8. So what does it mean here? In order to do steps number 9, the operations in steps number 9, we need an information from steps number 3, we need information from steps number 6, and we need information from steps number 8. So this is what this dependency graphs is all about. It's just to guide you on how to do the process for each of steps, what will be the input needed. Okay, if you run through the algorithm, you might need to refer to this dependency graph for you to determine what will be the input for each of the particular steps in these algorithms. Okay, now we start with steps 1. Okay, steps 1 is to find all nullable rules and nullable non-terminal. Nullable is mean null. A null value is actually an epsilon. In this case is epsilon. We call it is a nullable. Okay, so all epsilon rules are nullable rules. Okay, so the non-terminal defined in a nullable rules is a nullable non-terminal. So what does it mean? If you look into G5, a grammar G5, the epsilon is in rules number 3. So for rules number 3, the non-terminal is A. So A is called a nullable non-terminal. Okay, A is a nullable non-terminal. Okay, so the rules here, the rules number 3 is called nullable rule, where A is a nullable non-terminals. Okay, there are two different terminology here: nullable rules and nullable non-terminal. Rules number 3 is a nullable rules, whereas the non-terminal the A there in the rules number 3 is a nullable non-terminal. Okay. All rules in the forms of A goes to B, C, D, where B, C, D is all nullable non-terminal, nullables rules. Okay, if they contains all nullable non-terminals, means that the rules is considered as nullable rules. Okay, the non-terminal defined by these rules are also nullable non-terminals. Okay. So in other words, we say that a non-terminal is a nullable if epsilon can be derived from it. Means that if any non-terminal, okay, if the epsilon can be derived from it, is called a nullable non-terminal. And a rule is a nullable if epsilon can be derived from its right hand side. If the right hand side of the rules contain epsilon, so the rules is considered as a nullable rules. So understand that. Okay, nullable rules and nullable non-terminal. Okay, so in this case, for grammar G, we say that because the rules that contain epsilon is rules number 3, then we say rules number 3 is nullables rules, and the non-terminal A is a nullable non-terminal. All right. Okay, we have done step number A is to find the nullable rules. We know that rules number 3 is a nullable rules with A is a nullable non-terminal. Okay, that information is important for the second steps. Okay, second step is to compute the relations begin directly with for each non-terminal. Okay, for each of the non-terminal we have. So here the keyword is begin directly with. So the short form is BDW. Okay, BDW is stand for begins directly with. Begin directly with what? For each non-terminal. For each non-terminal in the rules. Okay. For grammar G15, we have a non-terminal S, we have a non-terminal A as well as a non-terminal B. We want to know what will be the begin directly with. Okay, so A, B, D, W, X, if there is a rules A goes to alpha, X and beta such that alpha is a nullable string. Okay, if it is nullable string, so a string with a nullable non-terminal. Okay, A represent a non-terminal and X will represent terminal or a non-terminal. Okay, beta will represent any string of terminal and non-terminal. Okay, let's look into the grammar. For grammar, the first rules. Okay, if you look into the first rules, the first rule is of S goes to A, B, and small letter C. Okay, small letter C, which is a terminal. Okay, so the BDW is for S would be A. Okay, that is from rules 1. Also, the BDW for S is a B. So also from rules 1. Why? Because A is nullable. Okay, A is nullable here means that the right hand side of the first rule is A, B, and C. Okay, if A will replace it with epsilon, means that the next the next string that will be after A or after the nullable will be B. Nullable means here is empty string. So A, if you replace it with the epsilon, means that it's empty. So if it is empty, means that we can start from B, because A is empty. So it's actually is nothing. So actually S can start automatically with B as well. So that's why the BDW for S can be A, it can be from B as well. Okay. that is why it's that here, because A is a nullable, so that S actually can start with B as well. Because when you replace the A with epsilon, means that you ignore the information or instantiation from the A. Okay, so the next non-terminal is A goes for the second rules we have A goes to BA. So you have the start with, actually the non-terminal start with begin directly with B. Okay, and of course rules number 3 we ignore it because it is a nullable, because it starts from epsilon. So the next one would be B. Okay, non-terminal B, this is from rules number 4, it starts with C. So we say that begin directly with B. So this is BW. We want to indicate for each of the non-terminal, it starts with what. Okay, for the rules number 1, it starts from A, it also can start from B when A is replaced with epsilon. Okay, for rules number 2, A can start with B. For rules number 4, B can start with C. So that is steps number 2. Now for steps number 3, we want to compute the relation begin with. Okay, so for these steps, actually we want to find the reflexive transitive closure. Okay, the reflexive transitive closure for BDW. BDW is the one that we get from second steps. Okay, so here for steps 3, we must represent it using BW, begin with. Okay, so begin with for each pair of the string that we have. Okay, for reflexive transitive closure, so there are 3 rules in order to write a reflexive transitive closure. Okay, first is you need to copy the pair that you get from BDW, which is from the previous steps too. Okay, so the first rules is to copy what you get from BDW, so these steps. Okay, this is actually from the previous steps. Okay, next is to find the transitive from this BDW. Okay, how to find the transitive is for the first rule, you see, you get S, begin with A. So then you look into the start with A, begin with B. So the transitive will be S, begin with B. Okay. Next one is S, begin with B, and then B, begin with C. So you have S goes to begin with C. Okay. That is 2 transitive from the BDW. Alright, next is to find the reflexive. For reflexive is to have all the input symbol for the grammar. Okay, for in this case, this grammar have S, so you contain S, begin with S. You have A begin with A, B begin with B, terminal B begin with terminal B, and terminal C begin with terminal C. So this is reflexive. So for steps 3, we need to find reflexive transitive closure. So this is all the reflexive transitive closure. Okay, now we look into steps number 4. Step number 4 is to compute the sets of terminal first x for each symbol x in the grammar. So what does it mean? At this point, we can find the set of all terminals which can begin at sentential form. Okay, so there are 2 here. first A. A means that a non-terminal, and where we need to find set of all terminals, B. So, and then the second one is first T. T here is a terminal. So what does it mean here? We need to find a first X. First X here would mean a non-terminal as well as a terminal in the grammar. Okay, in the grammar that we have. So in this case, we are referring to grammar 15. So we have a S, A, B, and a terminal B and a terminal C. So we need to find this in these steps. So what does it mean here? Let's say we want to look the information for first S. We need to refer to the output that we get from steps 3. Okay, in steps 3 we have S goes to A, S goes to B, S goes to B, S goes to C, S goes to S. So there are 5 informations about S here, but we only interested for the S that begin with a terminals only, because we want the information on the terminal. So these are the one that we interested in. S goes to B and S goes to begin with C. Okay, so first S is sets of B and C as a terminals. Okay, now let's look into A. Okay, for A, so looks into the output from steps 3. So for A, we have A goes to B and then A goes to A. But we only interested in A that begin with a terminal, which is A begin with B. So the result here would be B. First B. Okay, now look into a B. B we have B begin with C, B begin with B, and B only 2 there. Okay, only 2. So we're only interested in B that begin with a terminal. Okay, which is this part. Okay, so C. For first B, the same thing. We need to look into B, which is down here. Goes to begin with the terminals B, and the last one is first C, which begin with C as well. So that is the value for first X. First S is B and C, first A is B, first B is C, first B is B, first C is C. Okay, so that is the output for steps number 4. For steps number 5, you want to compute first of right side of each of rules. Okay, for this one, we want to find what would be the terminals for each of the right hand sides of the rules. Okay, for example, first A, B, C, this is the first rules. So we need to find first A union with first B. So for these steps, the operations would be unions, okay, to combine all the terminals for each of the non-terminals that we have. So first A, we need to refer back into the previous steps for what would be the first A. So I have copied it here, the result from the steps number 4. Okay, so it is first A is B. Okay, from here, this is from steps 4. Okay, A is B, union with first B, B is C. Okay, so here we get a B and C. Okay, B comma C, because A is a nullable. Okay, we can start from either A or we can start either from B. So we can start from terminal B or we can start from C. Okay, remember this is to find selection set. Okay, if A is epsilon, means that we can start with C. All right. And second rules is first BA. So the selection sets will be B. Okay, the first BA will be B. First epsilon will be empty, and first C is C. Okay, so if the grammar contain no nullable rules, so you may skip to steps 12 at this point. So until this point, if your rules has no nullables rules, then you can skip 6, 7, 8, 9, 10, 11. You can straight away goes to steps number 12. Okay. For in this case we have still a nullables rule, which is rules number 3. So we will look into steps 6, 7, 8, 9 until 12 in the next video. Thank you very much.